Okay. Question 7 to 9. Oh, I should probably tell you, this is 2009. Question 7 to 9, apparently. Just have a read of it. Okay. So, if you haven't paused it, you can pause it now to read it properly. But what I do is I look at this and there's a lot of words, and a lot of words scare me. So I kind of just skim it, right? Free fall without any fall. So this person's free falling. The person on this ride is carried up on a platform to the top. So going upwards, the top, a trapdoor opens and the person falls. So then she falls. Approximately 100 meters below, and so that's already here. Okay. There are shown as the mass decides to take the ride, takes the platform to the top. The platform travels vertically upwards at a speed of 5 meters per second. So this thing's moving upwards at 5 meters per second, then she falls. Sounds like fun. Okay, never mind me. Never mind me at all. What is her apparent weight as she travels up? So we need to look at all the things happening here. Her apparent weight is the normal force pushing her up. Okay, that's how we know we weigh anything. There's this chair's pushing me up, and that's why I feel like I have weight. And that's usually equal to mg. Okay? And that's if she's staying still, if she's not accelerating. So net force in her, these are all the forces, equals N minus mg. Okay? And this is her apparent weight. Is she accelerating? That's the question. Is she accelerating? Because we know net force, ma, equals N minus mg. Because it equals force. Let me try and show you. Net force upwards equals N minus mg. And that equals the acceleration of her. They say she's moving at a constant speed of 5 meters per second. So that means she's not accelerating. So 0 equals N minus mg. Or like usual, our weight, our apparent weight, is our mass times gravity. In the case, she weighs, I can't believe they told us what a lady weighs. 60 kilos. So 60 times 10 gives us 600. So we'll be repeating this theme for the next 2 questions. Okay. So now, what is the apparent weight as the platform slows to a stop? Slows to a stop at a uniform rate of 2 meters per second squared. So now she was going at 5 meters per second, and now it's slowing down so that she is going at 0 meters per second. So it's accelerating this way at 2 meters per second squared. Okay? So if we consider, we have to think about direction. We know normal is going up, mg is going down. Our net force up equals N minus mg equals ma. But acceleration is going down now. So our normal force, which is what we're trying to find, that's her apparent weight, minus her 60 times 10, 600, equals minus her mass, 60 times 2. Normal equals 600. 600, so we take that over, it becomes a positive, minus 120. That's 60 times 2. She apparently weighs 480 newtons now. Okay. And finally, an apparent weightlessness question. This is when the normal force, as we've been showing, it's like if she's standing here and she's falling down and the ground is falling down, she doesn't have any normal force pushing up. There is no normal force. There's no force pushing up. She's just falling with gravity, and she's accelerating in gravity. So that's when the normal force equals 0. That may have confused you, but I'll try and explain it now. The gravitational weight force is a force that pulls us towards gravity. That's our real weight, our true weight. That's our real weight. And that's still 600 newtons for her. It's still pulling her in. Well, that's mg. Now the thing is, apparent weightlessness, our weight that we feel, is what pushes us up. And that stops us from falling forever. Like if we were falling forever, something's stopping us. Otherwise we'd have a constant mg pulling us down. That was the net force. We'd always be accelerating inwards. So the weight we feel is that. So when we're in free fall, these are important words, there is no normal force. Therefore, normal force equals 0. Therefore, we are weightless. Apparent weightlessness. So those are important concepts. I'm sorry for my writing. Years of medical school has trained this into me. But that's roughly what you want to see in answer. If there's anything more, I'll put it online afterwards because I'm not an examiner. Awesome. How do I stop this? Here it is.